Good morning, everyone. Today I'm going to be talking a little bit about different types of energy sources. Now, I do apologize in advance. I have a list of words on the board, and I'm hoping I cover everything, but if I don't, please feel free to send me a message and ask me about something else. Even if I'm at home, I can record at home and upload to help you out for tomorrow's test. So this lesson goes out to my Nativity family, in hopes that maybe it'll help a little bit with tomorrow's test. So we're going to talk about renewable and non-renewable forms of energy. So first of all, a sustainable energy source is an energy source that can be maintained. In order to sustain it, typically you're looking for renewable energy resources. So what is the difference between renewable and non-renewable? Well, a non-renewable resource is a resource that cannot be renewed. For example, the use of fossil fuels. Fossil fuels are pretty much dead plants and animals that existed thousands, hundreds of thousands, millions of years ago. The reason it is a non-renewable resource is because it takes time for that dead and decaying matter to turn into fossil fuels, and we are using those fossil fuels at a much faster rate than they can actually be replenished. So we're eventually going to run out. So some of the common fossil fuels that you're familiar with, or the byproducts of fossil fuels, are gasoline. We pull the fossil fuels, the petroleum, out of the ground, and we actually distill them to make different types of gasolines, kerosene, oil for houses, lamp oils, and the gasoline that goes in your car. So it is used in many, many different ways to power many, many different things. For those of you who've ever lived up north, you'll be all too familiar with the oil truck visiting the house to put oil in the tank for winter fuel. So a renewable resource, and there are a lot of renewable resources out there, sadly they're not used as often. The sun is our major renewable resource. Okay, the sun is constantly producing fuel. For those of you who don't know how the sun produces fuel, it produces thermal energy through the process of nuclear fusion. Hydrogen and helium atoms are constantly slamming together. Hydrogen atoms form helium in our sun, and it's going to be going on for millions of years. So that thermal energy, that radiation, actually is collected into solar panels, and those panels actually convert the solar energy into electricity that can power our homes. It is a very efficient and a very cost-effective way of being able to utilize solar energy. Water actually is used for hydroelectric power. We use water in turbines, and it actually powers those turbines, and through that process, hydroelectricity is formed. Again, the power is converted into electricity. Wind is actually captured in windmills, and that process again will generate electricity. So these are all things that are renewable. The water obviously is something that can be recycled and continuously filtered. The sun is something that is continuously beaming, shining, and sending power to the earth. And wind, produced by the heat from the sun and the turning of the earth, and the earth is always turning, so we always have the constant production of wind. So as a result, these three are constantly being either recycled, renewed, or generated, and as a result, we have a sustainable, renewable source. So, looking at photons are actually involved with the use of solar panels, okay? Photons are actually used to convert in solar panels the electricity. So, geothermal energy, which I don't think I actually have up here, but geothermal energy is another great renewable resource. And the reason this is a great renewable resource is because when the Earth was being formed, there was a great deal of heat that was trapped in the Earth's surface, in the Earth's core. It's actually about 7,200 degrees Celsius. But the geothermal energy, you know, sometimes during volcanic activity and when we have cracks in the earth and you have heat that rises out, but we also have decaying atoms such as uranium. Uranium is a radioactive substance, and we have decaying atoms that are actually breaking down and releasing the energy through the process of their decay. So that is constantly renewing the heat in the Earth's surface, and that generates a great deal of energy for us as well. Now, although geothermal energy is a relatively inexpensive and renewable resource, there is one thing you do need to be concerned about, and geothermal energy, in building all the power plants that are required, it can cause a little bit of instability in the Earth's surface. So we have to look at ways to manage, making sure that we're not damaging the Earth and at the same time using the geothermal sources. So a greenhouse gas, for those of you who don't know, a greenhouse gas is a gas that actually will trap heat towards the Earth's surface. The most common greenhouse gas is carbon dioxide. Greenhouse gases are produced through the use of substances like gasoline, certain substances that release carbon dioxide in the atmosphere. You may or may not have heard of a carbon footprint. Basically, it's how much we leave behind as a result of our regular activities. So releasing byproducts of gasoline in the atmosphere, of the oils that we burn, factories that are burning things and releasing that smoke out of their smokestacks, that will actually release some greenhouse gases in the atmosphere. And what happens is the sun will actually beam down on the earth, but those greenhouse gases will behave like a blanket and they won't be able to leave as easily. And as a result, the surface of the earth will heat up. So, the law of conservation of energy is very important for you to know. There are 3 laws of conservation that you should know. The one that applies to this test is the law of conservation of energy. Energy cannot be created or destroyed. It is converted from one form to another. So what does that mean? Well, when the solar energy, the water energy, the wind energy, any energy produced from gasoline or fossil fuels enter into a system, they come out the other side, but they can come out in many different ways. However, if you were to add up the total, it will equal what went in. So if I plug my cell phone into the wall, for example, the energy that is coming from the outlet, the electricity, will go to powering my phone. Well, some of us say, well, sometimes my phone doesn't power very well. Well, if you notice, your plug may get hot. Not all the power is going to your phone. Some of it is being released as waste thermal energy. But thermal energy is still energy. It is going in more than one direction. So it's important to understand that you cannot destroy energy, you cannot create energy. You can take it, you can harness it, and you can convert it, but you cannot make it and you cannot destroy it. So, recycling is extremely important, and the reason recycling is important is because we are utilizing our resources, and there are many resources on the Earth's surface that are finite. What that means is they are not sustainable, they are not renewable, and if we do not recycle some of the materials that we have, we are eventually going to run out of those materials. One such material is a fossil fuel. So if we are not careful to utilize our resources, we are eventually going to run out of some of the resources. I'm going to address a couple of other types of energy. I don't know if they're on your test or not. And again, if there's something I didn't cover, please go ahead and post a comment on this video or have your parents send me a message, and I'll be happy to go ahead and upload something this evening really, really quick. So try to make sure you do it fast so I can get to you and get that video up. But I did want to talk about kinetic and potential energy. As I said, I don't have your textbook, so I don't fully know exactly what is on your test, but I did want to try to cover some forms of energy in hopes that it would help you. Kinetic energy is energy of motion. It is the energy that occurs as a result of something moving. And potential energy is stored energy, energy of position. My favorite way to explain this is utilizing a roller coaster. So, for example, if you are utilizing a roller coaster, when you are going up in the roller coaster to the top, that roller coaster over time, as you're going up, it slows down, and it temporarily hits the top. Well, when that happens, that roller coaster has now got its maximum potential energy. And its kinetic energy at this point is 0. Okay? So once it gets to the top, it then, of course, our favorite part of the roller coaster is it starts to drop. So as the roller coaster starts to drop, it begins to pick up in speed. Its potential energy is decreasing at this point, and its kinetic energy is increasing. And when you get to the point just before you hit the ground, your kinetic energy is at its max, and potential energy is at 0. So chemical energy is another type of energy, and it's basically energy that is produced from chemical reactions. We deal with that primarily. Again, atoms is really big when we're talking about chemical energy, because chemical reactions are based on the reactions between elements forming compounds or breaking down, and the energy that is absorbed or released as a result of these chemical reactions. So hopefully this has helped you a little bit. Again, if you have any questions, if you need me to cover something in a little bit more detail, please do not hesitate to let me know. I will be checking for responses, and hopefully this was of help. Thanks, have a great day, and good luck on your test tomorrow.